Hey guys, we're looking at another parallel lines question. This one though is in a slightly different context. Here we've got Lauren claims that the following four-sided shape is a parallelogram, and you can see the keyword parallel buried in that shape, and we want to know if she's correct, and then you've got to justify your answer, which is really just a fancy way of saying explain your thinking. Well, we need to remember that in parallelograms, opposite sides must be parallel in order for it to be a parallelogram. And what that means is, if we think about these two sides right here, AB, right, has to be parallel to CD, this side and this side, and at the same time, AD AD would have to be parallel to BC. So I'm going to check to see if those sides are in fact parallel, and if it turns out that this is parallel to this and that this is parallel to this, then we know that this is a parallelogram. We can say yes. If it turns out that these two are not parallel, or that these two are not parallel, then we could say it's not a parallelogram, since not all opposite sides are parallel. So the way to do that is to determine the slopes, right? If we know that this slope is the same as this slope, then we know that they're parallel lines. And if we know that this slope is the same as this slope, then we know that they're parallel lines. So it's really just a question of using that slope formula. So the first thing I'll do is I'll take a look at the longer lines here, AB and CD. And I'll see if AB and CD are parallel to each other. So first of all, I'll get AB. I'll get the slope of AB, and I'll say A is equal to, and so I'll call this my x1 and I'll call this my x2. So it's going to be 10 minus 4 over 6 minus negative 6. And 10 minus 4 is 6, and 6 minus negative 6 is 12, which is equal to 0.5. So my slope of AB is 0.5. So now I'm going to get the slope of CD and see if it is also 0.5. It certainly looks like it is, but we can't trust the visual representation. So I'll work CD right now, and I'll say, hey, A is equal to. So for CD, I'll call this my P1 and I'll call this my P2. So I'm going to go Y2 minus Y1, negative 4 minus 2, over X2 minus X1, negative 8 minus 4. That becomes negative 6 over negative 12, which is equal to positive 0.5. So this one, A is equal to 0.5. So far, this could be a parallelogram, right? It could be a parallelogram so far because these two line segments are parallel to each other. But that's not enough, right? It's not enough that A, B, and CD are parallel, although we know that that's true. We also have to see that AD and BC are parallel. In other words, the short edges here also have to be parallel. So I'll do that on the right side over here. And first I'll find AD. So the slope of AD. A is going to equal, I'll call this my P1 and I'll call this my P2. So negative 4 minus 4 over negative 8 minus negative 6. Negative 4 minus 4 is negative 8, and negative 8 minus negative 6 is negative 2. Negative 8 over negative 2 is positive 4. So my slope of AD is A is equal to 4. So now I'm going to check to see if this is also a 4. Let's see. Let's get the slope of BC. So for BC, A is going to be equal to, I'll call this my x1, y1. I'll call this my x2, y2. Again, the order doesn't matter. So I'm going to go 2 minus 10 over 4 minus 6. 2 minus 10 over 4 minus 6. That's negative 8 over negative 2, which is positive 4. So we can now say that CD is a parallelogram since all the opposite sides have the same slope. And we're done.